Now that we've been looking at slope-intercept form and we've been looking at slope and y-intercepts, we want to actually put them to use and use them to graph equations. So here are my steps for graphing equations. Please make sure that you've either printed out this template or written these down. These are the steps you're going to follow every time you go to graph an equation. We're going to start by rewriting it in this form. So notice that this form essentially has us solved for y, or has y by itself. Then we're going to plot the y-intercept on the y-axis. That's going to be our starting point. We'll use the slope, the idea of rise over run, to plot a second point. Then we'll connect the points with a straight line. So I'm going to go ahead and look at example 1. It is hard for me to be exact on these graphs because they are so small. So make sure that you are listening to this and hearing what I'm saying in case my points are off a little bit. But on example 1, first thing I want to do is I want to put it in y equals mx plus b form. It's already in that form, so I can skip step 1. Then I want to plot the y-intercept. Well, so notice that my y-intercept is -1. So going down 1 on the y-axis. Then step 3 says I'm going to use my slope. Well, I can see my slope is 3, or 3 over 1, to plot another point. So from my y-intercept, from my starting point, I'm going to rise 3, 1, 2, 3, and run 1. Then I would typically grab a ruler. However, I cannot use a ruler with a program I'm using, so I'm going to go ahead and try to make the straightest point possible. But connecting these points with a straight line would look something like this. I'm going to do the same thing with example 2, but notice in example 2, step 1 is not done for me. So I have to start by solving for y, so very similar to what we did in unit 2. So I'm going to go ahead and subtract 4x, and I get 3y equals 9 minus 4x, and I'm going to divide both sides by 3, and I'll now have y by itself. One thing that we didn't do in Unit 2, I'm going to take this a step further, and I'm going to go ahead and say that when I divide this whole side by 3, I'm dividing both the 9 and the 4 by 3. So I'm going to separate this, making this equation y equals 9 over 3 minus 4x over 3. Well, I can simplify 9 over 3, giving me y equals 3 minus 4 over 3x. So then I can go ahead and say, well, that's very helpful because now I know that my b, my y-intercept, is 3, and my slope, my m, is -4/3. And I can go ahead and follow the rest of my steps. I'm going to plot my y-intercept, so I'm going to go ahead and go up 3 on the y-axis, 1, 2, 3. There's step 2, and then using step 3, I'm going to go ahead and say I'm going to rise over run, so I'm going to rise down 4 since it's a -4. 1, 2, 3, 4, and I'm going to run 1, 2, 3. I'm going to go ahead and plot that point. Again, I would typically grab a ruler for this, but then I go ahead and I connect those with a straight line. And again, I should have a ruler so I do a better job of going through that point. My graph should look something like that. And notice that because it doesn't matter what order we add and subtract in, it's okay that I have b plus mx instead of mx plus b. Those do mean the same thing. Looking at 2 more examples. These, if you feel like you're starting to understand this, these would be 2 examples for you that would be good for you to try, or watch number 3 and try number 4. I rewrote the steps up here so I could follow them I could follow my notes. So you do not have to rewrite those down if you've already got them. The exact same steps as above. And starting on example 3, I start by putting it in y equals mx plus b form. I'm already there. So I'm going to go ahead and pick out my y-intercept and my slope. And according to step 2, I'm going to go ahead and plot that slope, a y value of 4, 4. And then rise over run, it tells me to rise down 3 and over and run 2. There's my next point. And then again, I just connect those with a straight line. It's a little better. And it should look something like that. That line's a little weird because I'm trying to go through both my points, and it's hard for me to hit them without that ruler. And then looking at one final example, again, if you haven't tried one, this would be a great one for you to try. First thing I'm going to do is I'm going to rewrite it in y equals mx plus b form. So I'm going to go ahead and subtract 8 to get y by itself. and I'll have minus 4y equals 5 minus 8. 5x minus 8. I forgot my x, so let me erase that. And then I'm going to go ahead and divide by negative 4 to get y by itself. Again, I'm going to take that extra step that we didn't take back in Unit 2, and I'm going to say that gives me 5 over negative 4x minus 8 over negative 4. Simplifying that just a tad, that's going to give me y equals negative 5 over 4x, because it doesn't matter where the negative is, but it just is a little bit nicer to have it on top. Negative 8 over negative 4 gives me a positive 2. So I can say that my b is 2 and my m, my slope, is negative 5 over 4. And I know according to step 2, the next thing I do is plot that 2 on the y-axis as my starting point. And then rise over run, I rise down 5. And I run right 4. And I plot that point. Since, just kind of going back to that same point that I just made about how it could be, the negative could also be on the bottom, notice that I would still be on that same line if I used this and said I'm going to rise 4 and go back, rise 5 and run back 4. So just again from that same starting point, if I were to rise 1, 2, 3, 4, 5 and go back 4, again, notice I'm still in alignment with those other 2 points that I've plotted. So it does not matter where the negative is. And that's it for plotting points. Again, please make sure you have these steps written down so you can use them as an aid when you're doing your practice, and make sure you have those with you in class.